Hello friends, and today we are going to study a problem number 4, which is based on when a signal having a numerator degree which is greater than denominator. Now the next coming 3 numericals are completely based on numerator degree is greater than denominator. So first of all, we have studied one power signal expansion method, or you can say power series expansion method. Over there also one condition is mentioned. Now, what is mentioned over there? A numerator degree can be equal but always greater than denominator. But if numerator degree is greater than denominator, or if numerator degree is equal to denominator, then what we can do? Then simply perform a division that we have done in power series expansion also. Now, here what we are going to do? In power series expansion method, we have calculated the sequence, but here we want answer in step response or in ramp response, which means we have to study all the properties once again to get the answer in inverse Z transform. So first of all, we'll see the question and then we'll move on to solution. Problem number 4. Find the inverse Z transform of x of z, and x of z is 1 plus 2z inverse plus z to the power minus 2, and here we have 1 minus 3z inverse plus half z to the power minus 2. Now here the degrees are same. If the degrees are same, which means you have to divide this function only once. If the degree is greater or more than 1, or you can say if the degree difference is more than 1, let's say 2, then you have to divide this numerator by denominator by 2. Similarly, we'll perform this solution, or we can perform the division one by one. Well, let's see first of all how to solve this question. Now look at here. Here the degrees are same, which means we are going to divide numerator only once by a denominator. Now here in question, one ROC is mentioned, mod z is greater than 1. Now if ROC is mentioned, or if it not mentioned, then don't bother. Our task is only to divide numerator by denominator. Now look at here. We have to divide the first element by first number. Now on both this side, the first element is 1. So simply we'll divide or multiply a denominator by 1, so that 1 into whole definition remains same. So I'll write whole answer as it is. Now what you can see, if I want to cancel this 1, then I have to change this sign. So that's why the sign will be changed for all the parts. Now 1 minus 1 is 0. Now here the minus sign is replaced by plus, so 2 plus 3 by 2, that is 2 plus 1.5, answer is 3.5. Now if you want to write this answer in a ratio, then also it is fine. If you want to write this answer in fraction, then also it is fine. Now here the answer is 3 by 2 plus 2, answer is 7 by 2. If you want, then you can write 3.5 also. Next one, here the value is 1 and here the sign is changed to minus, so 1 minus half, answer is half, but plus half. Now as I said, if the degrees are same, then you have to divide this part only by 1. Now as I said, if the degrees are same, then you have to divide numerator only by once by denominator, or else you can say that after dividing, if the remainder degree is lesser than divisor, then we can stop our division. Now look at here. Here the 1 is my quotient, this is my remainder, and this one is my divisor. Now how to write the x of z? Because we have done this division part, we can write our x of z like q plus r by d. So I'll show you how to write the next step. Now, one is my quotient, this one is my remainder, and last one is my divisor. Now, we can directly move on to inverse Z transform, but the condition or the problem is we cannot obtain directly the inverse Z transform of this whole part. So I'm going to consider this whole part is nothing but my x1 of Z. Now, let's say this is my equation number 1. So my x1 of Z is 7 by 2 Z inverse if you want, then you can multiply numerator and denominator by Z square so that you can get the answer in Z format, or else just keep this question as it is and factorize this denominator. Now I'm going to keep this question as it is, and first of all I'll factorize the denominator. The factors of 1 minus 3 by 2 Z inverse and plus half Z to the power minus 2 is 1 minus Z inverse and 1 minus half Z to the power minus 1. And let's say here we have two poles, then of course we will use two variables. And this is my equation number 2. Now simply just do one thing, multiply this left hand side on right hand side. So what you will get? I'll get this equation, and this is my equation number 3. Now what is the next step? I'm going to substitute the values of Z inverse in that, or you can say in this equation, so that you will get the numbers or the values of A and B. Now this one is my equation number 2. I'm going to substitute Z inverse equals to 1 in above equation. So what you will get? If I put Z inverse equals to 1, then all this Z inverse will be replaced by 1. Now here we have Z to the power minus 2. So we can write this Z to the power minus 2 by Z to the power minus 1 into Z to the power minus 1, which means we are going to find out a square of this element. Now we'll see later on, but next one is all this Z is replaced by 1. So look at here, this Z is replaced by 1. So 1 minus 1 is 0, and 0 into B remains 0. So this B value will get vanished. Now this will be our result. Now look at here what we have. Here we can take 1 square, and that will remain as a 1. Now next, this Z inverse is replaced by 1. So half into 1 is half. Next one, 7 by 2, and this Z inverse is replaced by 1. So what you will get? 7 by 2 into 1 answer is 7 by 2 and plus half. What will be the answer? Answer is 8 by 2, and that will be nothing but my answer will be a 4. Now here, the 1 minus half is a half. And if I multiply both the sides by 2, then my A answer is 8. Now similarly we will find out B value. But for that I'll substitute the Z inverse equal to 2. So look at here. This first z inverse is replaced by 2. So I'm going to write 7 by 2 into 2. Next, here we have z inverse, or you can say z to the power minus 2, and that we can write as a z inverse into z inverse, which means we are going to write this 2 value twice, or you can say we are going to take a square of this 2. Now next one, if this z inverse is replaced by 2, then 2 will get cancelled and 1 minus 1 becomes 0. So this whole term is replaced by 0. And now here this z inverse is replaced by 2. So 1 minus 2 is minus 1. So on right hand side, what we will get? Minus 1 into b. So next one, just do one thing. This 2 gets cancelled. So answer here is 7. Again, one more 2 is get cancelled. So only 2 will be there in numerator side. And what we have on right hand side? A minus b. 7 plus 2 is 9. And if I multiply both the sides by minus sign, so we'll get b is equals to minus 9. Now I'm going to substitute all the values of a and b in equation number 2. This one is my x of z, and I have substituted my values of a and b over here. Now I'm going to substitute this x1 of z value, but in equation number 1. So my x of z becomes 1 plus, here we have going to place the x1 of z value, that is this equation. Now look at here, I'm going to multiply z in numerator side and denominator side for both this function. So what you will get? So now we can apply inverse z transform on this function x of z. So if I apply inverse z transform both this side, then left hand side, look at on left hand side, here we have x of z. After applying inverse z transform, this x of z can be written as x of n. Now here we have 1, and we know that if z transform of del of n is 1, then inverse z transform of 1 is always del of n. Now this 8 is a constant. What we have? Z upon z minus 1, and inverse z transform of z upon z minus 1 is simple, that is u of n. Minus 9 is a constant. Now z upon z minus 1 is u of n, but here we have a half, and we know that a raised to n into u of n is always z upon z minus a, which means my a value is a half. So I'm going to write half raised to n, that is a raised to n, and into u of n. If you want, then you can take u of n common from the last 2 digits. And this is nothing but the inverse z transform of obtained or given function x of z. So this is the solution, and likewise we are going to solve, or similarly we are going to solve a solution for next coming numericals. But for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.